This video is about completing the square. We're going to start off with kind of a reasoning behind why we need to complete the square, and I think a good place to start is with an example. So let's say we have a quadratic x squared minus 3x plus 1 set equal to 0 that I'd like to solve. Well, this is a trinomial that looks like we might be able to factor it. Since the leading coefficient's 1, I know I can try to set up the pair of parentheses and put an x in the first place and an x in the second place. And I have to find two numbers that multiply to make 1 and add to make -3. Well, 1 times 1 multiply to make 1, but they do not add to make -3, so that's out of the picture. And then the only other option is -1 times -1, which makes positive. But when you add the two, you get -2, not -3. So this can't be factored. Okay, well, we also learned how to solve by taking square roots. Do you remember the first step of solving such a using the taking square roots is you need to isolate the squared term, which is just that guy. If we did that, we'd have to do the following. We'd have x squared minus 3x plus 1 equal to 0, and if we isolate that squared term, we'd have to add 3x to both sides, and while we're at it, we would also need to subtract 1, right? Giving us x squared equals 3x minus 1, and then if we square rooted, right here you'll notice something's kind of not right. We're going to have x equals plus or minus the square root of 3x minus 1. We never really isolated the x's on one side. We've made this kind of more complicated. So solving by taking square roots is not going to work. Right now we don't have a way of solving this quadratic unless we have another method, and this is where completing the square will come in. And we'll actually revisit this problem after I lay out kind of the way we would complete the square. So let's see what this is all about. So completing the square is really just all about writing any quadratic as a perfect, can't spell, let's try that again, a perfect square trinomial. Now, perfect square trinomials are really nice because we can factor them pretty easily. Let's just go through a couple of quick examples like we've seen in the past. If I have x squared plus 6x plus 9, this is a perfect square trinomial that we can easily factor into x plus 3 quantity squared. Another example, if I have x squared plus 8x plus 16, this is also easily factored into x plus 4 quantity squared. Now there's a relationship between this b value, or the x coefficient, and that last number. And it's not very obvious, but in general, if you have x squared plus bx, if I want to know what is this last number going to have to be in order for it to be a perfect square trinomial, what I need to do is take the b value, cut it in half, and then square it, and that will work to complete the square, making it a perfect square trinomial. So if I have x squared plus bx plus b cut in half squared, this is a perfect square trinomial. So let's write that. This is a perfect square trinomial in general. Now, the reason why that's so great is we can simply factor that into x plus whatever that b over 2 value is quantity squared, and then we can solve by factoring. Just to show you that this does in fact work, if we look back at this particular example, the b value is 6, and if we cut 6 in half and then square it, isn't that the same as 3 squared, which is 9? And that is what we had there. We had a positive 9, and it factored into just the b value cut in half over here. So that 3 really is just that 6 cut in half much like the way this general formula explains, we just have the b value cut in half squared when we want to have it factored. Let's do a couple of examples where we just try to create a perfect square trinomial. So what I want to do is, in this example, let's make this example 1. I want to find the value of c to create a perfect square trinomial. And then I'm going to factor. Alright, so here we go. Let's do 2 examples so we get a little repetition on it. In example A, let's have x squared minus 3x plus c. So now the idea is I want to find what the value of c is so that this trinomial becomes a perfect square trinomial. In order to do that, that c value, remember, is supposed to be whatever the b value is cut in half and then squared. So all I need to do is really replace the b value with the number -3, since that's, in this problem, what the b value is. So I'm going to do -3 cut in half and then squared, which really is just -3/2 times -3/2. Let's write that out, maybe just this one time. And if I multiply top to top, bottom to bottom, I'm going to end up with 9/4. And it's a positive number because a negative times negative is positive. So my c value is 9/4. What that means, guys, is I can rewrite this as x squared minus 3x plus 9/4, and this is now a perfect square trinomial. It maybe still looks ugly because it's got that fraction for that constant at the end, but I can factor this pretty easily. If you recall from the last slide, or if you look up, all I have to do to factor this is do x, and then it's going to be the b value cut in half, so I have to take -3 and cut it in half and square it, and it's factored. So this kind of finishes the problem off. I have this thing factored. By the way, for those of you who are skeptical that these are in fact equivalent, let's check by factoring, or foiling it out rather. If I have x minus 3/2 squared, remember that really means x minus 3/2 multiplied to itself, right? If I go ahead and multiply that out, I have x times x to get x squared. X times -3/2, that's -3/2x. The inner terms make another -3/2x. And then if you multiply the last terms together, there you get your positive 9/4. And if you combine these guys, because they have the same denominator and they're like terms, I'm going to end up with what, -6/2x plus 9/4. By the way, -6/2, isn't that really just the number -3? And that matches the original. So actually, this is quite useful. We can change a quadratic into something that we can pretty much easily factor. Let's do one more example, because I always thought this was challenging the first time I saw it. Let's do another one. Let's look at x squared minus 11x plus c. If I want to know the c value, I'm going to take the b value, cut it in half, and square it. So in this problem, it's -11 cut in half and squared. If I do that, -11 times -11 is positive 121, and 2 times 2 is 4. It's a very ugly c value, but nonetheless that's my c value. So I can rewrite this as x squared minus 11x plus 121/4. And now that is a perfect square trinomial. To factor it, it's just going to be x, and then remember, take the b value, -11, and cut it in half. That's what goes inside the parentheses. That's your constant squared. And this is factored. And that would be my answer. Let's do one example of how we can apply this now to help solve quadratic equations. If you recall, let's make this example 2, where we're going to go back to that problem I started off the video with, where I had x squared minus 3x plus 1 equal to 0. Now remember, we couldn't factor this, and we can't solve by taking square roots. So we're going to have to complete the square to do this. Let's write some steps over here so that when you guys are doing this in your groups or on your own, you have something to kind of help you get going. Step 1, I want to isolate or get by itself x squared plus bx and have that equal to just some number on the other side. So I want to only see the x squared and the bx on one side of the equation. Alright? That in this problem is just these two terms. So that means I got to subtract 1 from both sides to start off with. So I have x squared minus 3x all by itself. Now I'm going to leave room on purpose here, a little space before the equal sign. Of course these canceled, right? And on the other side, 0 minus 1 is just negative 1. So I've accomplished that first step. Step 2 is complete the square. Complete the square by taking the b value cut in half squared and adding that to both sides. Add to both sides. So here we go. Remember what we just did in the last example? We took the b value, negative 3, we cut it in half, and we squared it, and that is the number that will make this a perfect square trinomial. In this problem, negative 3 times negative 3 is positive 9, 2 times 2 would be 4. So what I'm going to need to do is I'm going to add a 9 over 4 there. That makes this a perfect square trinomial. However, I can't just magically add a 9/4 on one side of the equation where I like it. I need to balance the equation, and I need to add 9 over 4 to this side to make sure we have a balanced equation. Step 3. You can factor your trinomial. This is also what we did in the last step. It's just going to be x, cut the b value in half, and square it. And that's equal to, let's see if we can add this other side. If we have negative 1 plus 9/4, that's the same as negative 4 over 4 plus 9 over 4. 9 minus 4 is 5 over 4. So on the other side, if you just did negative 1 plus 9/4, you're going to get 5/4. After we have it factored, what I like to do now is solve by TSR. If you remember that, that's take square roots. Check it out. All I have now is an equation where I have a squared term that I can square root, and I can get by itself. So I'm going to square root both sides, or taser both sides, and I end up with, let's see if I can still squeeze this in, x minus 3 over 2 equal to, remember when you square root it's got to be plus or minus, and since I have a square root of a fraction, I'm going to square root the numerator separate from the denominator. So I have x minus 3 over 2 equals plus or minus the square root of 5 over square root of 4 is just 2. I have one more step. I don't want what x minus 3 over 2 is, I just want what x is. So I'm going to add 3 over 2, add 3 over 2 to both sides, giving me just x equals, because those cancel. And now I have to write this as 3 over 2 plus or minus the square root of 5 over 2. Now guys, there are two options here. I have one answer is going to be 3 over 2 plus the square root of 5 over 2, or 3 over 2 minus the square root of 5 over 2. Notice how they have the same denominators in this problem, and I can combine 3 plus radical 5 if I want over 2, and this one I can write as 3 minus radical 5 over 2. So you can write them like this, or to be honest with you, I would also be okay with just leaving it like this. But I want to make sure that you do realize there are two separate solutions to this problem. You'll have a chance to practice some more of these with some help in a group. I hope you have these steps written down so that you kind of have an idea of what you need to do. We'll talk more about it tomorrow. Thanks for watching.